Up to this point, I've mentioned that there is a geometry node and a transform node for each object. The geometry node is actually always baked down to a simple polygonal mesh object, which is then shown in the viewport or passed on to the rendering engine for rendering. But what do I actually mean by this? Well, let's quickly first have a look at parametric models. If you have a procedural teapot primitive as we have here, the geonode for this is simply a number of parametric curves that make up the description of a patch-based teapot shape. There are no actual polygons involved at this stage, simply a pure mathematical representation of a simple teapot model. This geonode also contains a number of parameters to define the basic characteristics of this shape in our scene. For instance, its radius and whether it should have UV mapping coordinates applied, and also whether certain elements of its form should be active or not. This allows us to turn off, say, the spout, the lid, the body, and so on. You can see these here on the parameters rollout here. You can see we've got a radius parameter, which as you can see defines the radius of the teapot. We've got a segmentation parameter here, where you can define how many segments it has. And you can, turn off smoothing or turn off the body of the teapot, turn off the handle, turn off the spout, the lid, decide whether you've got UV mapping generated and so on. If you look at these other parametric objects, you'll see that you have different parameters going on here. You can see you've got radius value here on this torus, you've got a second radius value, you've got a rotation value here, twist values and so on. And on this tube primitive here, you can see we've got two radii values with which you can define the radii of the tube. We've got a height value, and we've got segmentation values. We can see we've got segmentation along its height, and we've also got segmentation on its sides, although in this case it's actually called sides. But you can actually think of it as being segmentation as well. Now, the key parameter on all of these primitives objects is the actual segmentation values. And these values define just how many samples should be used along the mathematical curves that actually build the mesh object that we see in the viewport. The more segments we use, the more polygons we create, and ultimately the more accurate our final polygonal representation is compared to our original mathematical representation. So as we can see, the polygonal teapot that we see in our viewport, and also at render time, is in fact a rough approximation of the internal maths-based model. And this representation can actually be changed for better or for worse on the fly by simply animating the segments parameter. These objects, because of this, are often called implicit objects, and that's because the mathematics which define their surfaces and the segments are used to imply the final geometry that you actually see in the viewport. Now, there's a second type of model which is called an explicit model. Let's have a look at that now. Now, let's take that parametric primitive teapot node and change it into an explicit one. If we select the object and open our quad menu, you can see that in the bottom right quadrant, down here, we have the Convert To menu. This option allows us to convert our objects into one of the base geometry types of 3ds Max. We actually looked at this very briefly earlier in the DVD. It also allows us to convert between those geotypes when that's also logical. When we do so, we lose the ability to change, as an example, the segments of the teapot and so on. And that's simply because that node ceases to be a primitive object from that point on. In effect, its viewport mesh approximation is used to create a new node of the base explicit geometry type that you have chosen. What do I mean by explicit though? Well, I'll demonstrate this by actually changing it to one of the explicit types. And those are editable mesh, editable poly. Editable patch is actually still a type of implicit surface, as is a NURB. So let's actually convert it to an editable poly. So exactly what do I mean by explicit? Well, if you think about our teapot node, and what we had there was a mathematical description of a surface. In this case it was a teapot, but it could have quite easily been a sphere, cone, or whatever. No matter how closely you examine that surface, you would always find a perfect representation of the curve or plane or whatever shape it was that it modeled. Then this perfect surface is approximated in the viewport or at render time based on the segmentation parameters that you've defined. Due to these features, this class of object is usually called parametric or implicit surfaces. And it's called parametric for its reliance on some form of segmentation value or segmentation parameter to define its final level of tessellation. And as I said earlier, it's called implicit as the surface they define are implied by the maths rather than being explicitly and imperfectly modeled by crude polygons. Now, if we look at an explicit model, we're usually talking about a polygonal mesh. The reason it is described as explicit is because what we see in the viewport is also what we get at render time. Without polymeshes, there's no underlying mathematical model that's been interpreted into polygons. And what you see here is literally what you get, hence the term explicit. However, the waters were muddied here a few years ago with the rise of subdivision modeling, and the rendering technologies pioneered by Pixar in their animated short Jerry's Game. Under this system, the humble polygonal mesh was treated effectively as a control lattice that defined an implicit surface. Under this model, the vertices of the mesh were treated as if they were actually control points of a NURB-like surface that was then tessellated to whatever level was needed in the viewport and also at render time. Effectively, the polymesh was liberated from its limited traditional explicit role in modeling to the much more flexible implicit surface role. Of course, the choice was there. You could use the mesh as it always had been and treat it as an explicit model, or you could pop one of the sub-D nodes on top of it to use it as the base lattice of this new type of sub-D implicit surface. So I'll show you what I mean by that. If I just undo this conversion, and I'll actually knock this down a few. I'm just going to actually copy this teapot, so we'll use the teapot as a good example of an explicit and implicit surface. I'll copy that over there. I'm going to get the first version and I'm going to convert it to an explicit model, in this case an editable mesh. And now that is what you will actually see at render time. So if I zoom in a bit on it, and if I click on render, you'll get a very rough render. And you can actually see that the render here matches this object here. They're both exactly the same. And if I go to this object, and we'll just zoom in a little bit more, and I'll do another render. There we are. So you can see we've got quite rough segmentation around here, and that's something I want you to take note of. Now, what I'm going to do is I'm going to convert this object into an implicit surface. Now, before I do that, let's actually crank up the segmentation a lot. And if we do a render, you can see now at render time it's got these much smoother curves, and that's because we've increased the segmentation value and we're getting a better representation of that underlying mathematical surface. Let's put this segmentation back down, and now I'm going to convert it to an implicit surface like a patch here. Now if I go to 3D view, there's the teapot, and if we do a render, you can see we've got some sort of segmentation values going on there. So you can see you've got some options here. You've got view steps, which we can crank down, and you've got render steps. And those are two different segmentation values, one for the viewport and one for the render time value. So we can actually change that. And now if I do a render, you can see the segmentation has gone there. So as you can see, we've actually converted it from an implicit surface into another type of implicit surface by actually converting it into a patch. So let's undo things a few times until we get our primitive object back. And now I'm going to convert it into another type of implicit surface, in this case a NURB surface. There we go. And now if I do a render, again you can see it's actually a very smooth curve that you got going around here, and you can actually change that value by changing these options here, let's say to high. And now if I do a render, you see you've got much smoother curves going on here. So as you can see, Max offers a number of base objects, and some of them are implicit and other ones are explicit. And as I said, the water was muddied a certain amount by Pixar when they introduced this new idea of sub-D surfaces, and I can actually show that by getting this teapot, and if I put a modifier on it called turbo